In emergent coding, the compiling of native code only arises as a higher order complexity out of the locally simple interactions between agents. Basically, all agents follow some simple rules. They request information, they make decisions, and then they contract other agents. The main role of an agent is not one of directly compiling code. That's the higher order complexity. An agent doesn't need to worry about that at its local level. Instead, an agent's role is actually one of communications. It provides a service. If anything, an agent compiles as a service, a paid service. When an agent requests information from its clients, it establishes connections with those clients. And when it contracts other agents, it establishes connections with those suppliers. The way these connections are threaded together is very important as it allows everyone to get in touch in a decentralized way. So what is this information an agent requests? This information is finite, it's discrete, it's not arbitrary. And for this reason, we say that the agent has a finite set of degrees of freedom, what we call DOFs. An agent requests this information by requesting access to committees. Now here's where you're probably thinking, what the heck is a committee and why do you call it that? The best way to answer this is just to use an example. So here's an example set of DOFs for an agent called compare byte sequence. This agent will design the code to compare two strings and register the true or false outcome of that comparison using a Boolean flag. Now you're probably thinking that looks a lot like a library function. Okay, sure, but this library function will never need a compiler. And how do we bypass the need for a centralized compiler? By having each agent do their own small part in what becomes a distributed compiler, a Hive compiler. This first byte sequence DOF is the agent saying, Mr. Client, please make sure you put me in this special byte sequence committee with all the other guys who need this string as part of their designs, so that we can design the string ourselves. And the same for the second byte sequence. And the same for the condition. Committees are like the secret weapon of emergent coding, and the magic behind them? Committees contain nested committees. Which contain nested committees? An agent can actually join a committee and gain access to the nested committees like so, but the agent is not done yet. It's requested access to certain committees from its client, it's joined those committees, it's made some decisions. But how does it actually achieve its service of compiling code? By sneakily deferring that compiling to other agents. Compile as a service agents contract other compile as a service agents. And these agents, they request access to their own specific committees for their own specific design purposes. And you guessed it, the term committees of our own high-level committees can connect right up with our suppliers. What the agent has done by threading these committees together, we call this a design contribution. Now let's take a step back. This is just a snippet of what a live Hive compiler can look like with agents contracting agents, all threading together connections, getting all who need to be in touch for that particular program's design in touch. This Hive compiler of agents is different for every build. It's a very large and complex decentralized network created for each program designed by the system. Yet all an agent does is simple. It requests, it makes decisions, it contracts. It provides a design contribution. Here is a single agent's design contribution. Here is a single agent's design contribution. In fact, the program itself is just one design contribution. So hopefully now committees have earned a little bit of your respect. They are the magic behind emergent coding. They're how a guy over here gets in touch with a guy over here without anyone needing the big picture view.